Hello everyone! These videos are specifically geared toward those of you who manage photovoltaic projects in the field, from the design phase to handover to operations and maintenance, O&M. Now, we're going to explore how artificial intelligence is revolutionizing, in tangible and measurable ways, the end-to-end management of PV projects. And when I say revolutionizing, I'm not talking about future promises, but about concrete advances in the last 6 months. Technologies that are already operational, delivering real value, and transforming how we plan, build, and maintain a photovoltaic plant. The goal of these videos is not just informative. I want you to walk away with much clearer ideas about what AI solutions currently exist, how they are already being applied in real projects, and, above all, how you can progressively and strategically incorporate them into your own management processes as project managers. We know that the role of the PM has changed. Today, we are asked for greater risk control, greater speed, and greater decision-making precision. AI is one of the key tools that allows us to respond to these demands without overloading our teams or compromising technical quality. Throughout these videos, we will cover 6 main sections. We will analyze the new paradigm in project management with AI. We will look at the main types of AI applicable to PV projects. We will explore recent milestones that have marked a turning point. We will name platforms, data sources, and real-life tools. We will review practical cases with quantifiable results. And we will close with current challenges and the roadmap to 2026. So, let's start with the first section. What is really changing in the way we manage solar projects with the help of artificial intelligence? For years, photovoltaic project management has been closely tied to the project manager's experience, the use of spreadsheets, and reactive approaches that were activated only when a problem arose. But that is changing rapidly. Today, we are experiencing a true paradigm shift. We are moving from management based on intuition and reaction to predictive, proactive, and AI-optimized management. This isn't just theory. It's a necessary evolution to remain competitive and meet new standards of quality, profitability, and risk control. Let's look at the 5 major strategic impacts that AI is generating. First, design optimization. We can now accurately predict energy performance and adjust the layout even before construction. Second, significant improvements in construction planning and monitoring. Third, risk reduction. Not just financial, but also contractual and safety-related. Fourth, more robust decision-making thanks to real-time data, not just intuition. And finally, a much smoother transition to operations and maintenance thanks to digital twins and predictive systems. On the right side of the slide, we see a very clear comparison. Traditional PMs rely on experience, react to problems, and manually identify risks. And that comes at a cost. Lower accuracy and greater uncertainty. In contrast, PMs that manage with AI support start with analyzed data. Work with predictive scenarios. Automatically optimize the design. And detect risks before they occur. And what does this mean in measurable terms? A reduction in LCOE of between 3 and 8%. And faster implementation times of between 15 and 30%. Now that we understand the shift in mindset and the overall benefits that AI brings, let's look at the specific technologies that are making it possible. In this section, we'll focus on recent developments, the key milestones in the application of AI in PV projects between November 2024 and May 2025. Everything we'll cover here is already in real-world use, either on commercial platforms or advanced pilots in utility-scale environments. Here, we look at 4 key advances and 3 recent milestones that every project manager should be aware of if they want to remain competitive and anticipate time, cost, or performance deviations. AI applied to satellite and meteorological data improves irradiance prediction by up to 30%. This reduces uncertainty in the pre-feasibility stage and in the estimation of net energy generated. It improves the negotiation of PPA contracts with greater technical precision. Design algorithms optimize panel layouts, inverter and tracker selection, and improve performance prediction, P50/P90, to achieve an LCOE reduction of between 5 and 8%. This allows us to accelerate preliminary design and provide more technical support to justify CAPEX to financial investors. Furthermore, we have generative AI applications for generating conceptual engineering drafts, feasibility analyses, and initial technical documentation, which allows us to reduce documentation time by up to 40%. This reduction in deliverable times reduces our dependence on long cycles with external engineering. Finally, we have construction management platforms, where AI and drones are used for progress monitoring, early detection of deviations, and automated quality control. We can achieve up to 25% to 25% fewer repetitive tasks. The value achieved is proactive construction management, more efficient schedule control, and improved control over subcontractors. The most significant milestones highlighted in these months have been: in November 2024, Solar AI Designer is a parametric design platform with generative AI that automates layout optimization, peak power, and compliance with local regulations. It allows engineering proposals to be iterated without waiting weeks. In February 2025, Deep Solar Construction Analytics 2.0 is a drone and AI system that analyzes deviations in real time and allows comparison with the original schedule and plans. Construction risks are mitigated before they generate cost overruns or delays. Finally, in May 2025, the PV Digital Twin Framework generates digital twins of the project from design to operation and maintenance, simulating scenarios with predictive fault detection and asset traceability. This tool is essential for final project delivery and future predictive maintenance. These advances aren't futuristic. They're already here, and they're redefining the role of the project manager. Adopting these tools isn't optional, it's strategic, and whoever masters them first will have an advantage in terms of timelines, costs, and technical control. Now that we've seen the most recent milestones, let's focus on the type of artificial intelligence that's really behind these solutions. For a project manager, it's not necessary to be a programmer, but it is key to understand what each type of AI does, how it's applied, and which part of the project it has the most impact on. Machine learning. Machine learning is the most widely used foundation. In PV projects, we mainly apply it to predict a plant's energy performance and optimize the design. Detect risks from the planning stage. Identify failures early in commissioning. And automate the classification of incidents to prioritize resources. The notable thing here is that it doesn't work with predefined rules, but rather learns from the project's historical data or from hundreds or thousands of previous plants. Deep learning. This is a subset of the previous one, but more powerful in image processing. It allows us to analyze satellite or drone images to select the optimal site. Inspect the construction in real time, detecting visual errors such as alignment or missing modules. Use advanced thermography to find connection faults. Along with interpreting complex sensor data to improve performance. Natural language processing. This AI is especially useful for PM's documentary tasks, automatically analyzes contracts, licenses, minutes, and technical documentation. Extracts requirements, verifies compliance, and generates progress reports. It can even enable technical chatbots that support the team on site. Ideal for bidding, procurement, audits, and contract monitoring. We also have generative AI. This is the most disruptive AI currently. It allows you to create what-if design scenarios, automatically testing multiple alternatives. Generates complete technical documents from scratch. It can even design systems and components with generative logic. For example, if you're designing a 100 MWP plant and want to quickly see 5 layout combinations with string versus central inverters, generative AI can provide those simulations in minutes. Below, we see a very graphic summary of the project phases in which each AI is applied. In development, AI for feasibility, irradiance, multiple scenarios. In design, layout optimization, documentation, performance simulations. In procurement, supplier selection and contract analysis. In construction, drone inspections, progress dashboards. In commissioning, IV curves, digital twins, and failure analysis. As a PM, understanding these categories allows you to evaluate technology providers, justify investments, and above all, strategically apply AI based on your current project phase. In the following video, we'll delve into how platforms, data, sensors, and AI brains combine to make it all possible.